Here are some more home building and repair videos. Let's go ahead and jump into this thing with our first video. In this video, I am going to talk about probably the second biggest problem you're going to have if you put a granny flat in your backyard. And of course, the first biggest problem will probably be building permits, building planning department, and getting the project through their list of mind-numbing obstacles. And I'm not even going to go into the amount of money that you're going to have to spend for something like this. But with that out of the way, let's go ahead and get to our problem, and that is going to be plumbing, underground plumbing, the waste pipe plumbing system. And that will be the fact that the end of the waste line is usually going to be at the minimum height it could possibly be buried in the ground at the back of the house. However, if it's running from the front of the house to the back of the house, you can stop watching this video right now because you're going to be able to tie into it quite easily. But that isn't going to be the standard. Most of the time it's running from the back of the house to the street or towards the front of the house. And if you need to extend the plumbing drain line and you have a situation like this, then you could run out of room. You could actually create a problem to where the pipe would be either too close to the top of the soil to be approved by your local building department, or you could actually have it to where it would be sticking out of the soil, and it definitely wouldn't be approved by your local building department. Now, there is one more thing I'd like to point out when looking at this picture, and that would be the fact that your property might be sloping from the back to the front, and this usually allows the water to drain to the street and then down the street to the storm drain system. And if this is the case, then your pipe might be sloping the same distance as the top of the soil and you wouldn't have a problem. So again, another thing that you would need to consider. And of course, if you cannot connect to the back of the house, you are going to need to install a new plumbing waste line. And that line is going to need to connect into the existing sewer somewhere. And this is where it could really start to become expensive, especially if the connection you need is somehow underneath the street. But hopefully you won't have to go that far and you will be able to connect it somewhere on the property. And of course, the next problem will be all the obstacles that you could run into. For example, you will be digging a trench around your property because it's not going to make a lot of sense for you to go underneath the house with your plumbing, tear up your building foundation. It's going to make a little more sense to go around the house. And of course, this could be either side of the house also. A view of it from the bottom there, just trying to give you an idea of how the pipe is sloping in hopes of explaining something that makes sense. And of course, I have this drawn in here. Your pipes could be completely different. You could be coming off of here at a 45-degree angle, or this could be a little closer or a little further away. Just trying to give you an idea. You're not going to be able to look at this and say, hey, I'm going to be able to do this exact same thing. And for those of you who don't really understand what I'm talking about when I'm talking about a trench, this trench could start at 2 feet here, and then that could be the highest spot. Everything there would be sloping 1/4 of an inch per foot or 1/8 of an inch per foot, depending upon what size pipe you're going to be using, until you eventually get to the spot where you're going to have to dig a giant hole if you can't find that plumbing pipe, and I've had to do that before. Now, enough of the bad news. What would the trench look like if you could connect to the back of the house? It would look something like this. You would just simply dig a trench down to where your plumbing pipe was, and maybe an existing clean out would give you a clue, or you might have a bathroom in the back of the house. And of course, that would be a good place to start. And then you would just simply dig a trench to the granny flat or tiny home, whatever you're building back there. And something else that could save you a lot of money would be that you could simply raise the height of the building and then bring some more soil into the back of the property if the pipe wasn't deep enough in the soil, or if you simply needed a few more inches, or in some cases even a foot. You could simply raise the house and then put a couple of steps or a small stairway that would be going up to the front door. And again, I'm just throwing out a couple of options here. Because if I had the choice, I would definitely raise the house instead of digging that big trench and trying to find the main sewer pipe going around all of the other obstacles that would be required, like sidewalks, driveways, and of course big trees to get a new plumbing pipe in. Another idea, and this might not be feasible, would be to move the building a little closer to the house. Maybe everything would work out a little better, but of course you would have to make sure that your planning department would approve something like that. And even though something like this might not be feasible, you could always put it in the front of your house. But again, this is something that would need to be approved by your local planning department, because most of the time we have easements that require a minimum distance to the front of a building, the front of your home, and possibly the center of the street. And of course, that would be something your local planning department could help you figure out. And the last couple of items I want to mention in the video would be to make sure that you are on a sewer drainage system and not a septic tank. If you have a septic tank and a leach field, then there's a good chance you're not going to be able to build your tiny home or granny flat over the leach field. So keep that in mind also. And the last thing I want to point out, even though I already pointed this out in the video already, would be if the sewer pipe was located in the back of the house, maybe you have a back easement and maybe even an alley, something like that. If that's the case, then as I mentioned earlier, then you would be able to tie into this a little easier. If, of course, the building was going to be located in the back and not the front. This video has been inspired by multiple viewers sending me a variety of different questions about bathroom remodeling and some of the damage they have actually created from the process. So I'm just going to throw out a few things that they must not be teaching at your local do-it-yourself bathroom remodeling university. So first up on the list will be that we need to protect everything we possibly can that we are not going to be replacing. And this would include any floors and carpeting. And again, if you don't have any drop cloths, throw some towels down. And I'm not about to suggest using the best family towels you have. If you don't have anything, then go down and buy a drop cloth to protect what you want to protect. Because trust me, when you drop some ABS glue right here, or you spend a week and a half or a month, however long it's going to take you remodeling your bathroom, and you're walking and grinding the dirt and the grime into here, yes, now you're going to be replacing the flooring. Next up on the list, we have a toilet. Once you pull the toilet off, the water that is trapped inside of here will leak out of it. So make sure that you have some towels around the base of the toilet so that when the water falls out, you can actually soak it up. And if you need some extra room, put the toilet in your bathtub. Just make sure that you have a towel under the toilet if you are going to save the bathtub. And this was often something I would do if I worked on a house that only had one toilet, because I could simply take the toilet out of the bathtub, place it over the drainage hole, hook up the water supply, use it, and then remove it and put it back in the bathtub. But again, there are other options for that also, like portable outhouses. Next up on the list, I need to point out that if you have any wood paneling covering your walls, then you should be prepared for some type of damage, whether or not the paneling is nailed, screwed, or glued onto the drywall. And in some cases, you're going to find large holes where somebody removed some of the drywall, did some plumbing work, and then put some paneling over it. So if you have any type of paneling or wainscoting like this, then be prepared for some type of damage that might need to be repaired after you remove it. Next up, it wouldn't be a bad idea to put a plastic bag around anything that needs to be protected, like the water supply line, because you don't want any debris to get in here. And this seems to be another common problem I run into often with do-it-yourselfers, because here's what's going to happen. You're going to get a little bit of debris in here, hook the toilet back up, and then that debris is going to get shot right into the toilet valve and probably cause it to start leaking. Next up, make sure that you install all backing for towel bars and toilet paper holders, because the last thing you want to do is cover everything up and then go to attach your toilet paper holder to the wall and then find out that the drywall by itself isn't going to hold it up. Now, I'm not about to suggest that you can't use some type of plastic anchors, but I am going to suggest suggest that the backing is usually going to be the best alternative. And if you're in a hurry while doing the demo, you can plan on something like this happening, because there was so much silicone sealant on here, which tells me that they must have had a water leak here. And of course they did have a water leak there, because when I went to pull the wainscoting off of this section, it was wet in this corner. But that's not why the green arrow's there. It's there to show you the top layer of the vinyl flooring that got ripped off. And if you're working on someone's house and they didn't want this to happen, and you can't find a piece that's going to satisfy them as a replacement, then you might be replacing the entire floor. And of course, this was the first time something like this happened to me, but this doesn't mean it won't happen to somebody else watching this video. Next up, make sure that you use something to cover the toilet drain hole, because it is quite large and you could see where a tool like this could easily fall into it. And if something falls beyond your reach, well then I don't need to paint you a picture of just how much of a problem that could be. Next up, be prepared for old wires that don't have grounding wires in it. So here we can see a ground wire, a hot wire, and the white as a neutral wire. So if these wires need to be replaced for whatever reason, mainly because they don't have ground wires on them, then you need to make sure that this is done before you do any patching to the drywall. Next up on the list, some of the older boxes that I've encountered over time do become brittle and break easy, or end up having problems where the holes for the screws that attach the light fixtures to the wall end up being stripped out. So it might not be a bad idea to replace some of the older light fixture boxes. Next, make sure that you have the correct sized electrical boxes. For example, if you're going to have 2 light switches, then you're going to need an electrical box that has room for 2 switches. And another thing you might think about, if you don't have room for another electrical outlet in your design, then you might be able to simply add it to this box. So instead of using a 2-gang box, you will get a 3-gang box for 2 switches and 1 outlet. Next up, try to avoid drilling unnecessary holes. And if you can use an existing hole that's already drilled into the wall framing or any of the other framing components, then reuse it for your electrical wires, plumbing pipes, or any type of heating ducting. And a lot of these problems are created from people who don't bother planning out the project. And this should be the number one thing you take away from the video, and that will be any type of planning you can possibly make to reduce the amount of problems you're going to run into. Needs to be done before the project and not during the project or after the project. Next up, let's try to avoid cutting into the wood framing. Now, even though this isn't going to be a big deal, it's less than a 32nd of an inch, it looks like. And of course, I'm the person who put it there, so I can't beat myself up on this one. However, I have been watching some home remodeling programs on a variety of different networks, and I'm here to tell you that if you don't know what's behind the drywall, then don't grab a circular saw, don't grab a reciprocating saw, and don't use a sledgehammer to figure out what's behind there. And this translates to do whatever you possibly can to create some type of a hole to where maybe you can look into the wall before grabbing anything like a sledgehammer and beating into it and breaking one of your plumbing pipes or cutting through one of your electrical wires. Next up, if you are going to be removing a ceiling and you can't see what's behind it, then just be careful, because it might have loose rock wool insulation or a type of insulation that might actually be harmful to you. And if you're working in a small area like a bathroom and you don't have any ventilation in it, then make sure that you have some type of a mask on that will prevent that stuff from getting into your lungs. And I would like to suggest using some type of a fan in a window to blow all of this stuff out. However, this could be a problem if any of this stuff is harmful to you or to the environment, so I'm not going to suggest that. Next up on the list, and this is just like the old electrical boxes, and that would be to think about removing any of the old ventilation fans, or in some cases you might have some type of a heater, and replacing them with more of an updated version. Next, let's make sure that you're actually basically venting all of the exhaust from the bathroom out of the house and not into the attic. And like this one here, you might have to get creative every once in a while to make it fit. And if you don't want to have any insects or other creatures living in your attic, then make sure that you put some type of protective screening to prevent them from entering into your attic. And here's another thing most professional builders, contractors, and even someone like myself don't think about, and that will be whether or not any of the items you install in your bathroom have inexpensive or even any replacement parts available. Or at the very least, make sure that anything you're going to be burying into a wall behind tile, like a shower or bathtub valve, can be repaired easily. And of course, here's another thing that we forget to do. That would be to follow all of your installation instructions and use approved electrical connectors. And when I'm saying to use approved electrical connectors, this might not mean that you can use anything they sell at your local lumberyard or home improvement center. And to find out what you can or cannot use, you might need to contact your local building department. And of course, it's always going to be helpful to have backing in here for drywall, or if you need additional structural support for your ceiling fan. And even though I'm not going to be installing insulation in here because this is just a temporary repair, because I'm actually planning this out, I know this is hard to imagine, but eventually I'm going to remove the ceiling and remodel the entire bathroom. However, since my wife got tired of the fan not working and some of the other stuff in the bathroom that wasn't looking very nice, I had to go in and do some peacekeeping within the family and fix some of this stuff. Now, for those of you wondering why I have the word inspector here, this is simple because this is something that an inspector is going to be able to look up and see that there is no insulation up here. So if you are dealing with a building inspector and you think you can get away with some stuff, then you better think twice. Or at the very least, make sure that they can't see something like this. And a quick tip for those of you who don't have much experience finishing drywall, then I would like to point out that less might be better, or use fast setting plaster, because it's not uncommon for me to see people come in and just put big gobs of drywall mud on here to cover everything up, and then go back with a power sander and sand it down. That just doesn't make any sense. So definitely something else to consider. And this is one of my favorite tips, and another video that did pretty good on my channel would be to use caulking in the corners if you're going to be removing some of the drywall later. Now, even though I made this video as a temporary way to patch something like this up, I've had a lot of people comment and tell me that this is actually something they're doing as a different way to finish the corners as a permanent fix, not as a temporary repair. And for those of you wondering if I had any problems with this while we waited the few years to remodel the bathroom, then the answer is no, I didn't. And the caulking worked perfectly fine. And with that said, I am going to go ahead and end the video here. However, I am planning on making a few more of these videos, and for a variety of different repairs and remodeling projects. So in this video, I will try to provide you with some reasons why or why not you might not be able to build a deck over a concrete patio slab. And of course, the biggest problem here would be the concrete footings needed for the posts that are going to be holding up the wood deck. So let's go ahead and get rid of the stairs and build our deck anyway, and take a look at how I would do it if I was going to do something like this. And that would be to provide some type of raised concrete footings. And of course, that can be done a few ways, and I will provide you with that here in a little bit. And there's no reason why you need to remove the concrete patio slab. And I've even built brand new decks with concrete patio slabs under them so that people could clean them a little easier. So let's just say you had a 12-foot deck and a garden hose or a blower, and you wanted to clean the deck. You could just simply blow all of the stuff from one side to the other side. So keep that in mind, and of course that will depend upon the design of the deck. So let's go ahead and take a look at what the building department is going to require. and that will be a concrete footing. However, I won't be able to provide you with the exact dimensions because that might require a structural engineer, but I can tell you that I built plenty of these with 1 foot by 1 foot by 1 foot footings. So that would be a 1 foot square by 1 foot this way, except the 1 foot is going to need to go below the top of the soil. Or in areas with frost lines, you're going to need to go 12 inches below the frost line. And again, you might need to check with your local building department for more information about that. So not too difficult. You're simply going to create a hole that you're going to be able to fill with concrete for your concrete footings. Now here's the reason why most of you are probably watching this video, and that's to find out if you can just simply attach some type of a post base bracket to the top of the concrete patio slab, and then simply drill a hole into it and use some type of a anchor fastener. And the answer to that question is probably not. Even though I've seen this done before, and I've been to houses where it has been done, and I didn't see any problems with it. So I will leave it at that. If you are going to do something like this to support your deck, then you might not ever have any problem structurally with it. And if you were paying attention, I used the word might. Maybe not, but you could also have problems with this, especially when you go to sell your house and there are no building permits to be found for your deck. And that's probably going to lead the building inspector to wonder if there are any concrete footings to support your deck. Next up, let's take a look at a few more options for the concrete footings. And one of those would be to leave the concrete slab as it is, but dig underneath the existing concrete slab so that you have enough room for your new footings. Another option would be to saw cut the concrete slab so that you can dig your holes for the concrete footings. And the last option would be to get a sledgehammer or a jackhammer and simply just break a section of the corner off so that you can pour your concrete footings. And this option might be eliminated depending upon how difficult it is to dig around your soil or underneath the concrete slab. And of course, whether you're going to be able to get to it from two sides or from one side like this over here. And you could always dig this out a little further so that you have access to get the dirt out from underneath here, and then use some type of a form board to prevent the concrete from spilling over into the hole or into an area where you're really not going to need any concrete. Now this idea might not work for everyone because you could break a big section of the slab off, and that might require you to pour additional concrete. So don't shoot the messenger. I'm just kind of throwing this out there as another alternative. And of course, the square hole here, depending upon the location of where the footing is going to be located. For example, in this situation here, it's not located near the edge. Therefore, you wouldn't want to just take a sledgehammer and just beat a big section of the patio slab out. However, I will leave that up to you because it's going to provide you with another option, whether you rent or use a concrete saw or a sledgehammer. And of course, by doing this, you're going to be able to use the hardware that sets in the concrete. And this is going to provide you with a better structural connection. And it's always going to be good to make sure that the hardware is up at least 1/4 of an inch above the concrete slab. And in a situation like this, we removed enough of the concrete so it would be easier to dig. However, on the other side, we didn't. We just removed enough so that we could pour our footing to support the post. And the last suggestion I would like to make is one that I have already made, and that would be to create some type of a raised footing. And some building codes are going to require you to have at least 6 inches here. And that brings us to the end of the video. If you found this information helpful, make sure you let us know by hitting the thumbs up button. And don't forget to check with your local building department to get permits for any modifications to your home, especially if you're planning on selling it in the future, because otherwise you're going to have to get the permits then anyway. In this video, I am going to provide you with some of the problems I ran into when calling for a framing inspection. And one of those things will be the fact that you are not ready for the inspection. Now, don't be confused with a roof sheathing inspection. You don't need to call for a framing inspection if you're not ready, but if you want to cover the house with your roofing paper, then you can call for a roof sheathing inspection. But you can't call for a framing inspection unless all of your windows are in, the fireplace in this case, along with the plumbing, electrical, heating, and air conditioning ducts, and even the exterior doors. And there's a reason why I put this at the front of the video, and that's because I think it's the most important tip I could provide you with in this video. Next on the list, make sure that the plumbers, electricians, or the heating and air conditioning folks haven't drilled any oversized holes or cut any notches in any of the structural lumber that could create a problem for the framing inspection. Now, as we can see here, they have taken what looks to be like a chainsaw, and I've seen this done plenty of times, and cut what appears to be some heavy-duty structural framing plates. And by looking at this piece here looks like it's less than 2 feet wide. And I'm simply basing this off of the 16-inch on center spacing for the wall framing studs. And something like this might require a fix from the structural engineer, because the first strap is going to go to about here, and then this way 4 feet. And then you're not going to be able to get something from here going this way. So this might require a 6-foot strap. However, I wouldn't want to be the person who nailed the strap on and then had to remove it and then possibly remove some of the framing because it's all split. And for some of you, you're probably even thinking, well, why not put a 4-foot strap on this side and then go to the other side of the wall and then put a 4-foot strap on the other side? And to that, I would say clever. But what if the engineer doesn't want that many nails in this section of the wall framing? So again, something to think about before you call for the framing inspection. Next up on the list would be to take the building plans and go around the entire project to make sure that the correct building hardware was used and installed correctly. And for whatever reason, I have a hard time believing that this strap right here was going to work because it's a thinner strap than I'm used to seeing coming off of a 3x plate. And I'm even going to speculate that this strap, even if it was approved, should have been used to connect the 2 top plates together or moved up. And if you have a 2-story house, you will need to consider the stairway. And for this particular house here, the stairway has a couple of problems with the structural connections. And I'm not going to go into a lot of details about their problems because there's usually not enough information on the building plans to show how all of this stuff connects together. However, I am going to provide you with a couple of building code problems that your building inspector might not like. And one of them will be whether or not your stairs encroach into the minimum distance on a landing, or even, as we will see here in a few seconds, in a hallway. Another thing you should check will be the individual riser height along with the depth of the treads to make sure that they are all the same size. Now, the biggest problem area you're going to run into on a set of stairs is usually going to be at the top or at the bottom steps where the stair builder might have miscalculated something. And if that is the case, then the stairway might need to be removed and rebuilt. Now, as I mentioned earlier, sometimes you're going to have a problem where the stairway is sticking into the minimum width of a hallway. And if that is the case, then the stairway is going to have to be redesigned. And sometimes it's going to be the architect or the engineer's fault because they might have a beam in the way or the architect miscalculated some of the measurements. And I've seen this myself personally. And last but not least, with our stairway, we need to talk about the guardrail, which needs to have a minimum height in most cases of 42 inches. And that would be measured from the top of the finished floor to the top of the guardrail. So not only will it include walls like this that are sitting on top of the floor above, it will also include the walls that are attached to the stairway. Or should I say the walls that would be protecting people from falling off of the stairway. And of course, another problem you could run into will be any changes or modifications made by your construction workers. And even something like this could be a problem for the structural engineer. For example, if he needed a 10-foot overall length on this particular shear wall to provide him with the bare minimum required by the local building department, and you move it 2 inches in or 1.5 inches, then it could be a problem. I'm not suggesting it is going to be a problem, but these are problems that you need to be aware of. And trust me, I've seen plenty of them that have created plenty of problems for the building inspectors. Even something like this, where the structural engineer drew these pieces of building hardware in, and of course they needed to be installed, and somehow created a problem for the stair builder. And I don't think something like this is going to be difficult to fix. However, it might require what I'm going to talk about next, and this is going to depend upon the building inspector, or the mood of the building inspector, or whether the building inspector likes you or not. The fact that they might require some type of paperwork with a stamp on it from the structural engineer for any changes from any modifications or alterations that a construction worker might have made that isn't already on the building plans. Like this toilet here, where it looked like it was in the way of the double joist, and you can see here where the layout marks are on the glue lam beam. So at one time the double joist went through and connected to the beam, but now we'll definitely need the approval of a structural engineer and a detailed drawing of how to make this repair. And for those of you wondering just exactly how big of a deal something like this is, well, I can tell you from experience that it's usually going to cost somebody a lot of money, and in some cases it can hold the job up. I remember one time working on a project where my dad was building a custom home next to another framing contractor who was building another home, and all of a sudden we didn't see any more work going on. And one day I decided to go over there and just kind of look around and notice that they had notched a glue lam beam for a gas pipe. And then within a few weeks we found out why nobody was working on that job, and I'm guessing it took about a month before people started working on that project again. And of course, another problem you could have is if you use the wrong building materials. I mean, if you don't want to have any problems with the building department, structural engineer, or architect, then why take it upon yourself to make any modifications to anything on the building plans? And another thing, if you're not building a piano, look out for the concrete contractor and move this over a little bit and line your column up with the edge of the concrete. Another concern for using the wrong materials will be to check all of the floor sheathing, roof sheathing, and the wall sheathing, along with your structural shear panel, to make sure that it's all the right size and grade, and make sure that it's all nailed correctly and with the right nails. Another common problem, and even though I can't see it, there might be an anchor bolt here. However, I doubt it, because there's a pin here someone drove in that probably isn't doing anything, especially if it's the same pin that's used for the 2x plates. Just don't forget that you need an anchor bolt located within 12 inches from every framing plate break on the exterior walls. And most of the time, a hold down is not going to replace an anchor bolt. Now, don't ask me why, because it sure seems like it should. Next up on our framing inspection checklist will be any type of fire blocks or draft stopping. And this stairway provides us with an excellent example of how the fire blocks were installed correctly, even around the landing. Now let's take a look at a fireplace chimney draft stop. And when completed, there will be a round pipe for the chimney coming through this hole with a square piece of metal surrounding it to block off the draft stop. And of course, the draft stops and fire blocks are used to reduce or eliminate the amount of fresh air that can be drawn into a fire and reduce the possibility of a fire entering into the area above the blocks. And even though it doesn't look like this is blocked, there's a good chance it's blocked from below. And you can see a good example of that by looking at the one here going into the ceiling of the second floor. Another problem you could run into, and these aren't always going to be easy to find if you don't know a lot about construction, because it might not always be on the building plans. However, if your building inspector does know a little bit about construction, then it could be a big problem. And that, of course, would be any structural load-bearing beams that are going to be transferring weight from above to the wall framing. Might require more than one trimmer on each side, or even a 4x4 post. And on this particular project, I found about 4 problems like this. And even though this might not be a problem, it seems to be a bigger problem when you have a girder truss sitting over a window or a door header that might be a 4x6 when it really needs to be a 4x12 or larger. So girder trusses are definitely things to look out for whenever you see them sitting over any type of an opening. And of course, the last tip I want to provide you with to keep everyone safe will be to clean up the job site. And I'm not about to suggest this will always help with your inspection, but it's something I made a habit of doing after working for a contractor who swore up and down that it did make a difference. In this video, I will attempt to explain what a drag truss or a drag beam or a drag loaded beam or even a collector beam, whatever you're going to refer to it as. And basically what this beam is going to do will be to provide some type of resistance from strong winds that will be applying massive amounts of pressure to either side of the building, and then transferring that load through the beam and then through the shear wall into the building foundation. So if we just had the beam without the wall, we might not get very much resistance. However, we are going to get some resistance because any amount of pressure that's going to be applied to this side can be transferred through the beam and then distributed to the other side. So the beam without the wall is going to provide us with something. However, the wall will definitely increase the amount of resistance, and that's usually what you're going to be looking for if you're talking about any type of drag load. And of course, you are going to need a structural footing for this so that you can install your hold down anchor bolts along with any other anchor bolts you need to firmly secure the bottom of the shear wall. And don't forget, in some cases, the hold down bolts will be quite long, and in some cases you might require 4x6s or even 6x6 posts to increase the strength of the shear wall. So not too difficult. We have a rigid structure that's connected to a rigid building foundation that is going to reduce the amount of the forces applied to each side of the building. And in some cases, you are going to use a roof truss to transfer the drag load from one wall to the other wall, or from one section of the house that needs a little more stability to a structural shear wall. And try to avoid looking at this truss as something you're going to find as a standard model, because a drag truss could be 2 trusses nailed together or even 3, and will probably require some type of structural building hardware to connect it to the other wall framing components, like the exterior wall. Now let's go ahead and take a look at the shear panel. And again, this might not be the same design you're going to be working with, but here we have a structural piece of plywood that is about a 1/2 inch thick, and will have nails going all the way around the perimeter of the plywood, and then of course nailing into the other truss components and the wall framing studs. And it won't be uncommon to use some type of building hardware. And here is another example of the structural hardware being used to attach the truss to the upper wall framing plates. So again, not too difficult. The load is going to be transferred through the truss and then through the shear wall into the building foundation. And I would also like to point out that additional building, fastening, and connectors might be required to transfer the load through the ceiling or through the roof sheathing and then to the perimeter of the exterior walls. In this video, I will be providing you with enough information so that you can cut your own shed roof rafters, no matter how far they're going to be sloping. And of course, I need to bring up the point that I have built roofs like these before without cutting any seat cuts in them. And to give you a better idea what I'm talking about, you're only going to be taking about 1/8 of an inch out of this 2x8 to create the roof rafter seat cut. And of course, the seat cut will be located on both ends of the roof rafter and will end up looking something like this. So just a small notch out of the 2x8 or whatever material you're using for your roof rafters. And after you have one laid out, you can use that as a pattern to mark and cut the rest of the rafters. Now, before we continue, I just want to provide a brief description of what we're actually doing, how you create a shed roof. And that's usually going to be by having one wall taller than the other wall. So the wall on the right side is going to be 6 inches shorter than the wall on the left side in our example. And since the span of the building is 12 feet, then that's going to provide us with a 1/2 inch per foot slope. And the minimum for this building would be a 3-inch difference in the walls, providing us with a 1/4 of an inch per slope. And if for whatever reason that kind of doesn't make sense, I can give you a better idea by telling you that we have a 12-foot span. And if there was a 12-inch difference in the wall height, then we would have a 1-inch per foot slope in our roof. And hopefully that makes sense. Take a look at our seat cut. Again, 1/8 of an inch is the distance here, along with 3.5 inches here that would represent the width of the framing plates. Next up, let's take a look at what the roof rafter would look like after it was cut, sitting on top of the building foundation. And again, this is just to provide you with another point of view that might be helpful for you trying to figure out just exactly what we're doing. And of course, here's the 6-inch difference, which is represented by 4 1.5-inch thick wall framing plates, or should I say 2x4s. And since we're going to be using the building foundation to lay out our roof rafters, and as you can see here, we have it positioned in the desired slope in the same way it would have been when it was up on its side, except for now we've laid it down flat on top of the building foundation. So here we have our 6-inch difference, and we're going to use this line here to represent the difference in the height of the wall framing plates to lay out the roof rafter. Now this is where you need to pay attention, because you need to line up the edge of your roof framing lumber before the seat cut is cut at this point here with the building foundation edge, and not this point here. And you'll see a little bit more of that here in a little bit, because it's going to be more common for everyone to line up this section of the lumber with the corner of the building foundation. And in reality, it's not going to make that big of a deal when it's all said and done if you do make that mistake. So again, our 6 inches and how it's lining up here with the building foundation. Next up, let's go ahead and get started with our first method. And with our first method, we are going to lay out the 6-inch marks on the building foundation on one side and on the other side. Then we are going to position the roof rafter materials that do not have any seat cuts in them yet in the proper position. Now in this example here, I'm going to go ahead and line up the top edge of the roof rafter with this point here, which is the point we need to line it up with. We don't line it up with this edge. We're going to line it up with the other side. This is the point we're going to line it up with, as you can see here. Otherwise, we're not going to be cutting a notch out for our roof rafter. And hopefully that makes sense. Next up, let's cut a couple of 2x4s, and you'll need to make sure that the corners are square, or at least this one here is square, or a 90-degree angle from this edge here. And these can be however long you want them to be. Just make sure that this edge of the block lines up with this edge of the building foundation, and that this point of the block lines up with this corner of the roof rafter, because we're going to use this right here to lay out and mark the seat cut for our roof rafter. And we can see it right there. We have our nice seat cut, and of course what it would look like if it was notched out. Have our little cut there, and hopefully that makes sense. Next up, let's go ahead and take a look at the bottom here to provide you with the reason why we need to line this part of the roof rafter materials up with this point here. And you could always measure over. If you have a wall framing plate that's 3.5 inches wide, then you could always just make a mark here so that you can line this part of the roof framing lumber up with this point here and not this point here, so that you can lay it out and mark it properly. So again, just another view of it there. what it should look like when you're lining it up. So you're going to line it up with those 2 points, this one here, so that you can lay out the upper seat cut, and of course the one at the bottom. Otherwise you won't be able to lay out the bottom seat cut. And I'm not suggesting you won't be able to lay it out, because you could simply transfer the mark from the top to the bottom and it's going to be close enough on a low slope. However, that might not work out the same with a steeper slope. Now I've worked my way up to the grand finale, and that of course is going to be this method here. I think is going to work the best, because the previous method might make it difficult to lay out and mark the bottom seat cut. So in this method, instead of working from this side of the roof rafter, we're going to work from the other side with our 2x4s. So let's go ahead and give you an idea of what the rafter looks like with the seat cuts and laying them on top of 2x4s. And again, these 2x4s can be however long you need to make them, depending upon the slope of your roof. And of course we can see where we're lining it up with this edge here. So let's go ahead and start with our regular lumber that doesn't have any seat cuts in it. And with our 2x4 sitting on top of the concrete foundation that is nice and square, and with the edges lined up with both sides of the building foundation, we can now position our roof framing lumber at the top and the bottom. There's our 6 inches. At the corner, remember we need to line it up with this side, so again you can see how this method here might work a little better. And in order to figure out our seat cut, we're going to do the same thing we did with 2 pieces of 2x4, except we're going to measure the top piece so that it works out with the desired measurement we want to have for our seat cut depth. And if you're using square lumber, you should have a gap here. However, you're not going to have a gap on the other side. And in order to make this pattern here, we're just going to measure from here to here and then subtract the amount we want to have for the desired depth of our seat cut. And here I'm making my seat cut about 3/8 of an inch at the top here. So the next step would be to trace all the way around the 2x4 so that you end up with lines looking like this. Then we will use a straight edge like a framing square to extend the line forward. And by now you get a good idea what this seat cut is going to look like. And of course everything is nice and straight. Like I said, you're extending a straight line here that is parallel to the building foundation. And you're going to do the same at the bottom so that you end up with 2 seat cuts. And of course we have a new seat cut, and this one here is going to provide us with an additional benefit. However, you might not be able to do it all the time. So for example, if you have a structural engineer involved in the project, you might need to ask them if you can cut into the framing lumber. Otherwise you're going to have to go back to the original seat cut I had that was about 1/8 of an inch here, because sometimes the engineer isn't going to allow you to notch into the lumber this much. However, as we're going to see here in a little bit, I will provide you with a reason why I did it that way, because it's going to provide us with a better structural connection. However, keep in mind that this is just an additional method, another thing you can do. And often in my videos, I provide you with multiple variations that will provide you with a similar result. And of course, one more thing I need to mention, and this is very important, and that would be to lay out and even cut your pattern that you're going to use to lay out the rest of the roof rafters. However, don't even think about cutting the rest of the roof rafters until you've checked to make sure this one actually works. So for example, after you frame the walls and brace them off to where they're not moving, throw the roof rafter up there and see if it actually works or if you need to make any type of modification to it. In this video, I will provide you with the lumber sizes for this type of stairway. that I think is going to be one of the easiest stairways you can assemble with a small porch. And something like this might work great for a set of stairs where you have a door that opens out instead of in, where the building codes require a landing. And in my opinion anyway, a stairway like this is safer for somebody who's going to be opening and closing a door. However, you would need to check with your local building codes to verify whether or not the stairway will work in your area. Now, the thing I like about this stairway is that I think it will work great almost anywhere, including areas where it snows and you're dealing with frost line footings. So for example, if you have a 5-foot frost line in the ground and all of your footings need to go below 5 feet and will require a lot of extra work, then a stairway like this that simply sits on top of the ground might be cheaper to build. However, it might not be approved by your local building department. Again, you would need to check with them because this isn't going to be considered a permanent set of stairs because you're going to be able to move it. Where if a stairway like this had footings, then it's going to be considered permanent and part of the property. And of course, you could rotate this stairway in this direction or in this direction. And since you're going to be able to move this stairway, you can always have it in this direction in the winter and this direction in the summer if that works better for you. So let's go ahead and focus on the stairway, take another look at it here, give you an idea of what it's going to look like when it's done. And I don't imagine this thing is going to weigh very much either. And the thing I like about it is that if the bottom board rots because it's going to be in contact with the ground, then it can easily be replaced if you use screws or some of the building hardware that I'm going to show you here in a few seconds. So let's go ahead and take the stairway apart. All of these components are going to be the same, and you can always change it. You don't have to go with the ones I have here. However, the side pieces might not be able to change. And since most building codes require a 3-foot minimum stairway, this is what we will be using on this particular project. So your 2x4s and your 2x6s for the decking and the stair treads will all be 36 inches or 3 foot. So here we're using a 2x6, 2x6, and a 2x4, and then back here we're going to be using 2x4s. Now let's go ahead and take a look at these side pieces and give you the measurements of what they're going to be. And keep in mind that this is a computer generated model, and because I have never built this, then these measurements could actually be off a little bit. And if they are, please let me know through an email or by leaving a comment in the comment area so that I can make the necessary adjustments. So here we have 5 foot 11.5 inches for those of you who might not be able to see that. And up here we have 5.5 inches or 60.5 inches. And then 4 foot 1.5 or 49.5 inches, and 3 foot 2.5 inches or 38.5 inches. And that will give you your side pieces. Now let's go ahead and put everything together. We're going to start with the bottom section first. And even though I'm showing you that we're using 16D nails, you can use screws also. And I would imagine a 2 3/4 inch or a 3-inch screw would be fine. And since it's going to be outside, make sure that it's at least galvanized or stainless steel coated. And then we can go ahead and assemble the second section. And you can always assemble these sections and then set them on top, or attach this board and then this board and then this one here and then maybe these 3 here. Again, whatever is going to be easier for you to do. Now, you can always attach the upper section to the lower section by angling some screws or nails. And of course, this one here is just to give you an idea of how the screw is angled. Or you can use some type of building hardware like this strap. And if you use screws instead of nails, then you're going to be able to take this apart a lot easier. So if this board needs to be replaced because it rots over a period of time, and you've used screws, it's going to be easy to replace it. Now, for some of you, you're probably thinking, hey, why not use treated lumber? That's fine. And I say go for it if you live in an area where you might have a lot of moisture in the ground for long periods of time. For example, maybe more than 3 months out of the year. And then go ahead and attach the next section. And here we have straps on the outside. And if you connect everything together with straps and you don't attach it any other way, then you're going to be able to take this apart in sections a lot easier. And for some of you, you're probably wondering, well, how am I going to clean this area underneath it? And I don't think that's going to be that difficult, because you can just take the stairway and flip it over on its side, clean the area, and then reposition the stairway. Next up, let's go ahead and put the last section on. And of course, that can be attached with the building hardware or the screws. And of course, the building hardware can be attached to the outside or to the inside if you want it to look a little better. And again, I don't think this is going to be a big deal. For example, whether or not the straps are going to be located on the outside or the inside, because you're going to be able to just simply flip the stairway over, start pulling some of these pieces apart if you're using screws, and replace any of the damaged components. In this video, I will be trying to help out one of our viewers and at the same time maybe helping out a few other people who are dealing with a sagging roof ridge and an older house that has 2x4 roof rafters and maybe a 1x6 ridge, and maybe you don't even have a ridge at all. And at the same time, try and give you a brief explanation of what's going on here when you might have rafter ties going across. And of course, some of you think that they're ceiling joists, and they aren't. These are rafter ties. These are meant to prevent the walls from spreading out. And this would work kind of like this. As there is weight applied to the roof rafters, maybe from snow or something else, or even just the weight of the roof itself, if you do not have the rafter ties, then the weight of the roof eventually is going to sag down, or should I say could sag down. And without the rafter ties, the walls will actually spread out. As the walls spread out, the roof rafters and the ridge will start to move down also. And now, if you do have a roof that's in really bad shape, you might need to remove and replace it. However, in this video, I'm going to provide you with an idea that might work. And this is probably where I'm going to lose most of you, because I'm going to say that it might work. It won't always work. And this, of course, is going to depend upon the existing damage to the existing roof. Now, the first thing I'm going to suggest would be to use at the minimum a 4x6. And I believe the individual who emailed this question wanted to use a 4x4, and I just don't think a 4x4 is going to be enough. But I'm not going to discount the fact that we can't bolt them together or somehow connect a few of these together to make something a little stronger than a 4x4. At the same time, I need to point out that these aren't always going to be easy to get in, and you might need to cut a little more off of one side at the top so that you'll be able to shove it into this section so that you can pull it into the other side. And you can see here where this one's a little bit shorter, and yours shouldn't be that much shorter than it needs to be to get it in and then pull it over. So here you can see where we're a little bit farther away. It'd be nice to have it a little closer to maximize the length of our beam so that we can have as much of the beam sitting on top of the wall as possible. Now, as a general rule of thumb in construction, the minimum distance here is 1.5 inches. So keep that in mind, because once you pull this one over, you're going to have between 1.75 inches and 1.5 inches on each side. And of course, here you can see where the beam is shaped to the top of the roof rafters, and that'd be on both sides. And as we can see here, it's just sitting about 1.75 inches on each side. And again, if you can figure out another way to get it in, go for it to where you won't have to notch as much. But in order to slide this in on this side, you're going to have to take a little more off off of this side than you will on the other side. Again, unless you can figure out another way to do it. So here we have it. It's a little bit lower than the other side. If you remember on the other side, it was just to the bottom of the roof rafter. And of course, now that we have our first beam in, we can cut a second beam. And again, if you want to make this a 4x10 or something a little larger, a 4x4, whatever you want, these are just examples. And this is not structural engineering information because I am not a structural engineer. So I'm just kind of throwing this out there. And if you think it will work for you, then give it a shot. And with the upper beam here, we're going to be able to cut it a little bit closer to the top of the roof rafter than we did with this one here. So here it's sticking over past a little bit, but we're really not going to have that on the other side. Now I did put a jack along with some type of a post that we're going to be able to use to raise the ridge, but I need to point out, and hopefully this makes sense, that you're not going to be able to attach the beam to the wall framing on both sides. Now you will be able to attach it on one side, but this other side needs to be loose because as you raise the roof ridge, there's a good chance that you're going to be pulling the walls back in, and that's not going to happen if this beam is nailed at both ends of the framing plates. And you might even need to raise the beam a little bit. So let's say that you raise it, you got it supported, there's a lot of weight on the beams, then there's also going to be a lot of weight on the walls, and this could prevent the wall from moving. So you might need to bring the jack back over here and raise this up just a little bit, and then watch this as it pops back in, it'll snap in a little bit. And again, hopefully that makes sense. So let's go ahead and take a look at the other side where you can see where the beams are going to be shaped right on the money. Next up, let's go ahead and grab a piece of plywood. I'm using 1/2-inch plywood here. You can use larger or smaller plywood. And I'm just kind of using this to connect the two beams together to make them a little stronger. And hopefully this actually does make them a little stronger. I mean, if there's one thing I can't stand about most of the people that show you how to do repairs on YouTube, is the fact that they don't show you what it looks like 5 or 10 years from now. I'm not trying to be deceptive, and hopefully these ideas will work, but again, no guarantee. And there are other ways to connect these beams together. I've seen it done before where they drill a hole all the way down the center and then grab a long bolt with some washers on the end and then bolt it together. And this is actually something that I've seen done before that does work. But don't get misled and don't think that by putting two 4x6 beams together that are 5.5 inches wide, providing you with a total of 11 inches, that you have a 4x12 beam. That's probably not going to happen. However, you might have something strong enough that's going to allow you to make this type of a repair and raise the ridge a little bit, or at the very least prevent it from sagging any further. So next up on the list would be to add another beam, and you would follow the same installation instructions as you did for this one. And I really can't tell you where to put them in your roof because you could move these beams over a little further in either direction. So you could space them a little closer together or further apart if you need to install a shorter or a longer beam here. And in order to get this beam in here, you might need to remove one of these rafter ties or even another rafter tie. And if you're going to put a full length beam all the way across here, then the beam might need to go in first. So again, hopefully that makes sense. And then you could always place either 1, 2, or 3 jacks on top of the beam and then start raising the ridge. And if there isn't a ridge, then you might be able to start raising the rafters. And if you have any questions about any part of the process that just doesn't make any sense or something that I might have missed, then feel free to leave those questions in the comment area or email them to me and I will answer them as soon as possible. And of course you can see that the beam is located in the center underneath the ridge and has a variety of different supports here. And you can see this one here, I kind of notched it at both ends so they could slide under there. And then that one you could always screw to the side just like this one here where we're using a 4x4. You could just simply screw it to the side of the ridge. And of course our brace here, we're using another brace. However, this might not be necessary, just depends upon your project. Because if the roof isn't moving because it's got solid sheathing on top of it and it hasn't moved in years, and something like this probably isn't going to make that much of a difference. And again, another method here, we have a 2x4 going underneath the ridge and then something on the side, and you would just simply nail or attach this board to the ridge or even to the rafter if you didn't have a ridge, and then attach it to the other supporting block and then to the beam. Now, even though I'm not showing all of the connections everywhere, everything in this example needs to be firmly secured to the other components, and that could be done by a variety of different methods, including using straps and framing anchors and different types of building hardware. So again, just a different method. Here we have a 4x4 with a notch in it. Here we just have a 4x4 under the ridge. And here we have two 2x4s turned around. This one is shaped like this on this side here. And then this one here, we just simply use two of them. One that would look like this, and then we just simply flipped one of these around and then nailed it to the other side here. Another method for this would be to lower the beam and use hangers. Instead of having the beam sit on top of the other beams, you could simply hang it off of them. And again, you might need to do this for a variety of different reasons. And if this is the case, you might need to notch the rafter ties around the beam or connect them to the beam somehow. Okay, a view of the hanger, and here we're using a 4x10. However, you can use a smaller or a larger beam. And here I pulled the plywood back a little bit and connected it to the beam itself. And I actually like this idea better instead of going over the plywood. But again, if you use longer nails or screws, whatever you were using to attach the hanger to the beam, then it might be okay anyway. And here I went ahead and installed the other cross bracing so that I could have at least one connection to the gable wall here. And of course this goes all the way through and can connect with nails or screws into the gable stud, and then you could use framing hardware like we have here, attaching the brace connector to the beam, giving us a solid all the way through connection. Definitely another thing to think about, along with a view from above. And if you're looking for a little more support, you could always add a 4x4 or something larger. And I really don't see where something like this would be a problem. And in some cases, you're even going to be able to have it sit on top of the footing, at least partially. And again, just another suggestion, view of it from the other side. And of course, a 4x6, something a little larger. And of course, it is notched over the footing there and sitting directly on top of the garage slab. You can add whatever you want. You want to put some treated on here, knock yourself out. And of course, framing anchors will be handy, anything to connect it securely, and maybe even a strap here. But you do need to make sure that everything is connected nice and tight, along with a view of how the beam is still going to be underneath the roof sheathing. And that brings us to the end of this video. So if any of this made sense or helped you a little bit, then make sure you hit the thumbs up button. And don't forget to visit our website. I believe if you go to the repairs section, the repairs tab, and then click on the framing tab and then click on the roof framing tab, you should be able to find a few more repairs like this one.